Now, let's look at example 6. We want to find the limit as x approaches infinity and as x approaches negative infinity for the function f of x, and then describe the end behavior of the function. First, let's start with the limit as x approaches infinity. So we have the limit of 3x minus 2 over square root of 4x squared plus 5 as x approaches infinity. Now, if we look at this limit as x approaches infinity, the numerator gets very large, and the denominator also gets very large. So this is an infinity over infinity type of limit. But because there is a square root in the denominator, we need to be careful. We are going to simplify the expression by factoring inside the radical. So from 4x squared plus 5, I factor out x squared. From 4x squared plus 5, I factor out x squared. I have 4 plus 5 over x squared left inside. Next, I am going to take the square root of x squared. Square root of x squared is absolute value of x. This is a very important step. Do not change square root of x squared into just x automatically. It is really absolute value of x. Now, because x is going to positive infinity, so x is positive. So in this case, absolute value of x is x. Remember, this is an infinity over infinity type of limit. So we need to divide both numerator and denominator by the highest power of x of the denominator. So in this denominator, the highest power of x is just x. So I divide everything by x. So in the numerator, I have 3x divided by x is 3. And 3 divided by x is 3 over x. In the denominator, I have square root of 4 plus 5 over x squared. As x approaches infinity, 3 over x approaches 0, and 5 over x squared approaches 0. So I get 3 minus 0 over square root of 4 plus 0, which is 3 over 2. So the limit of the function f of x as x approaches infinity is 3 over 2. Now, I need to find the limit as x approaches negative infinity. Since this is the same function, so we start the same way. We factor out x squared, and then we take the square root of x squared. So I have 3x minus 2 over absolute value of x times square root of 4 plus 5 over x squared. Now, this time, x is going to negative infinity. So x is negative. That means absolute value of x equals negative x. When x approaches negative infinity, the absolute value of x is not equal to x. It is equal to negative x. So now we rewrite the limit as 3x minus 2 over negative x times square root of 4 plus 5 over x squared. Now simplifying again, divide top and bottom by x. So I have limit as x approaches negative infinity of 3 minus 2 over x over negative square root of 4 plus 5 over x squared. As x approaches negative infinity, 2 over x approaches 0, and 5 over x squared approaches 0. So I have 3 minus 0 over negative square root of 4 plus 0. Which is negative 3 over 2. So the limit of f of x as x approaches negative infinity is negative 3 over 2. Now, let's use these two limits to describe the end behavior of the function. As x approaches infinity, the function approaches 3 over 2. And as x approaches negative infinity, the function approaches negative 3 over 2. So the graph approaches different horizontal values on each side. On the right side, the graph approaches y equals 3 over 2. On the left side, the graph approaches y equals negative 3 over 2. So the function has two horizontal asymptotes.